For today's video, we will answer a geometry challenge coming from one of our followers. And the question goes like this. Let's start with a square with a side length of 24 units. Now, let's cut the square like this. And then, what we're going to do is to flip this portion like this, such that this point divides the side of the square into two equal segments. Now, the question is, what is the area of this triangle? Now, you can pause this video if you want to give this problem a try. Now, suppose you pause this video. Now, let's see if you got the correct answer. Alright, so to answer this kind of question, we will use the given information. Now, first, this point right over here divides the side of this square into two equal segments. Therefore, these two pieces becomes equal to 12 and 12 units. So 12 plus 12 will give us 24 units. Now, let's have the whole square again, like this. And why not? Let's call this side be equal to x. If this is x, we know the whole thing must be equal to 24 units. So this side length must be equal to 24 minus x. Now, since we fold this square, the side of the square, these two pieces, these two segments must be equal. So this piece must be also equal to 24 minus x. And let's focus on this right triangle. This is a right triangle because this is a square. Now, using the Pythagorean theorem, we have x squared plus 12 squared equals 24 minus x raised to the power of 2. Simplifying this, 12 squared will give us 144. 24 minus x raised to the power of 2, this will give us 576 minus 48x plus x squared. So, let's replace the right-hand side with its equivalent. Now, at this point, if we subtract x squared on both sides, x squared on the left-hand side and on the right-hand side are gone, this is just 0. Now, rearrange some terms a little bit and subtract 144 on both sides. 576 minus 144, this will give us 432. Divide both sides by 48. 432 divided by 48, this will give us 9. So the value of this x must be equal to 9. So we have here a right triangle, 9, 12, and 24 minus 9, this will give us 15. So 9, 12, 15. And now, we know the side length of this right triangle, but our goal here is to find the area of this triangle. So we need to find the measure of the base and the height. Because since it is a right triangle, we just need the base and the height of this right triangle, and we're done. We can now find the area of this triangle. Now, to find the length of this right triangle, what we're going to do is to use similarity theorem. Because in this figure, I see a lot of similar triangles. Now, let's say, for example, this angle, let's call this as alpha. Why not? So this angle, let's call this as beta. So alpha plus beta must be equal to 90 degrees. Since it is a square, this is 90 degrees also. So we have here 180 degrees. We have beta. And this angle, if we add these two angles, must be adds up to 90 degrees. It follows that this angle must be equal to alpha. And if this is alpha, the other angle is also beta. Now, vertical angles are congruent. This angle right over here must be also equal to beta. And if this is beta, the other angle must be also equal to alpha. So these three right triangles are similar to each other. And to find the length of those sides, let's call this as A. Let's call this as B, and let's call this as H. Now, if we find the value of B and H, we can now find the area of this right triangle. So the area of a right triangle must be equal to base times height divided by 2. So, in order to find the area of this triangle, we need to find the length of this B and the length of this H. Now, to do that, we will use the similarity theorem. So let's have this ratio. So we have 9 over 12, or the side opposite of the angle beta, over the side opposite of angle alpha. And it must be equal to 12, the side opposite of angle beta, over the side opposite of angle alpha. So we have 12 over A. Now, to solve for the value of A, let's cross multiply. 12 times 12, this will give us 144. Divide both sides by 9. So we have A must be equal to 144 over 9, or simply equal to 16. So the value of this A must be equal to 16 units. Now, this is very important to find the hypotenuse of this right triangle. And to find the measure of this hypotenuse, we will use the Pythagorean theorem. So this is just square root of 16 squared plus 12 squared. 16 squared is 256, and 12 squared is 144. 256 plus 144, this will give us 400. Square root of 400, this is just 20. So the hypotenuse of this right triangle must be equal to 20 units. Now, since we know the side length of this square must be equal to 24 units, we now have 20 right over here. Therefore, the remaining side, or this h, must be equal to 4 units. So this h must be equal to 4 units. Now, how about the value of b? Again, we will use the similarity theorem. So we have b over 4, the side opposite of angle beta over the side opposite of angle alpha, must be equal to 12 over 16. Now, to solve for the value of b, let's cross multiply. 4 times 12, this is just 48. Divide both sides by 16. 48 divided by 16, this will give us 3. So the measure of this side B must be equal to 3 units. And we found the value of B and H. So we can now find the area of this right triangle. This is just 3 times 4 all over 2. 3 times 4 is 12. 12 divided by 2 is 6. Therefore, the area of this triangle must be equal to 6 square units. And therefore, given this information, the area of the triangle must be equal to 6 square units, and that is our final answer. And as always, we are done.